Okay, so it's probably time to start this afternoon. Welcome everyone to this session of SLE. So the session is entitled Modeling, whatever modeling means in that context. We have three exciting presentations during this session, three research papers that will be presented. The first one will be about blended modeling, and I think we will discuss about textual and graphical notations. The second one will be about model comparison, and the third one will be about heterogeneous modeling versus viewpoint. So it's going to be a very exciting session, so please feel free to follow the talks and to ask all the questions. We will take a few minutes at the end of each talk for having a Q&A part. And that's it. This being said, I think we can start with the first presentation. The presentation will be given by Muhammad. And the title is Enabling Blended Modeling of Timing and Variability in EAST-ADL. So please, Muhammad, the floor is yours.
Okay, thank you. So good afternoon. I am Waseem Anwar, and I am going to present our research work titled Enabling Blended Modeling of Timing and Variability in EAST-ADL. This work is supported through Bumble and Modave projects. So this is the presentation outline. I will start with the background of this research, followed by the problem statement. Then I will discuss few state-of-the-art approaches. Then I will explain the proposed blended modeling framework, followed by the proof of the concept implementation. And finally, I will conclude the presentation with future directions. So what is blended modeling? So the concept of blended modeling was first introduced by Ciccozzi as the activity of interacting seamlessly with a single model, referred as abstract syntax, through multiple notations. Concrete syntaxes allow a certain degree of temporary inconsistency. So the runtime synchronization between graphical and textual notation is a key characteristic of blended modeling. Blended modeling aims at boosting the development of complex systems by enabling seamless multi-notation modeling. So experiments have shown that blended modeling has the potential to maximize the throughput of stakeholders involved in the modeling activities. EAST-ADL is a domain-specific modeling language for automotive embedded system. It is based on the 4 levels of abstractions: vehicle, analysis, design, and implementation. So at vehicle level, technical feature model are developed. And at analysis level, different concepts like analysis functions are available for the modeling and analysis features. So this allows to perform the early analysis on the system model. The design level is divided into two further components: functional design architecture and hardware design architecture. So functional level design is developed through the FTA, and hardware-related concepts are modeled through the HTA. Finally, the implementation level is dedicated to the other languages like AutoSAR and RCM. In addition to these levels, there are other packages in EAST-ADL like requirement, dependability, variability, and so on. So these packages can be applied at any of these levels as shown here. For instance, the timing constraints can be annotated in the system model through the timing package. So this is the overall architecture of the EAST-ADL. So on top of EAST-ADL architecture, several tools have been developed supporting tree-based diagrammatic modeling for automotive embedded system. For instance, EA-Top, MetaEdit Plus, Robust, these are few to name. The interoperability among various EAST-ADL tools is achieved through EXML. It is an XML-based exchange format that represents the serialized form of the EAST-ADL meta-model instances. So what is the problem we are going to solve? So currently, EAST-ADL tools traditionally focus on the diagrammatic notation rather than the textual one. So this limits communication across different stakeholders, and it is not possible to create models that do not fully conform to the meta model to ensure rapid prototyping and evolution of contents. So such issues severely affect the productivity and time to market objectives in automotive domain. So to address these issues, blended modeling environment for EAST-ADL is desirable to support both textual and diagrammatic notation for system modeling. facilitate the runtime synchronization between notations, and provide the tool-independent implementation to work with the existing EAST-ADL tools broadly. So the notation of blended modeling may seem similar to or overlapping with multi-view modelings. So multi-view modeling basically based on the viewpoints that can be composed of one or two models, while blended modeling focuses on the provision of multiple concrete syntaxes for a single abstract syntax. So the runtime synchronization between concrete syntaxes with temporary inconsistency is a key in the blended modeling. So blended modeling has been explored from different perspectives in industrial settings. This can be broadly categorized into two classes, UML-based DSML and meta models. So, for instance, in 7 author applied the blended modeling to HCL artist environment to support the modeling of state machines through graphical and textual notations interchangeably. In 8, author applied the blended modeling to Ericsson Hive DSML. So this shows the effectiveness of blended modeling in industrial settings. So EAST-ADL was introduced in 2004 under the EAST EA project. Since then, several aspects at different level of abstractions have been investigated and evolved. So there is a long list of areas that have been investigated. I am just highlighting the few important areas like the verification and analysis of timing constraints have been frequently researched. Similarly, safety aspects in line with the ISO 26262 standards have also been frequently researched. So it is evident from the state of the art that the blended modeling offers enhanced modeling flexibility to boost collaboration, lower modeling time, and maximize the productivity. In addition to this, EAST-ADL has been explored in different areas like timing analysis and safety. But the blended modeling support for EAST-ADL has not been targeted yet to the best of our knowledge. So to get the benefits of the blended modeling in automotive domain, in this research work, our goal together with our industrial partner Volvo is to provide blended modeling features for EAST-ADL. So now I'm going to explain the proposed framework. So this is the current situation based on the EAST-ADL architecture. Several tool chains have been developed like EA, Top, Robust that support the graphical editors. So the system modeling can be developed using different modeling entities using different packages like variability, timing, and so on. So this model are represented in EXML to support the interoperability among graphical tools. So for the provision of the textual notations, we exploit the XText framework where the first step is to define the XText grammar for EAST-ADL packages of choice. This can be structure, variability, timing, and so on. So this leads to a textual editor supporting the modeling in textual notations. In the second step, deserialization and information extraction has been performed using the EXML from the graphical editor. So at this step, the different entities from the graphical editor have been extracted. So the extracted information from the graphical editor cannot be directly propagated to the textual editor due to the syntactical differences between the graphical and textual notations. So for this, at step 3, transformation need to be implemented for the seamless change propagation from the graphical editor to the textual editor. So at this point, the changes from the graphical editor are propagated to the textual editor. At the step 4, transformation need to be implemented to convert the textual instant model into the EXML format. This is essential for the change propagation from the textual editor to the graphical editor. So at step 5, serialization is performed as most of the graphical tools only operate on the serialized EXML. So this leads to the updated EXML, and in this way, the changes from the textual editor are propagated back to the graphical editor. So in this way, the step 2, 3, 4, 5 are executed iteratively to achieve the blended modeling in EAST-ADL. So for proof of concept, we select two EAST-ADL packages, timing and variability. This selection is based on the industry partner recommendation. Then the selection of syntax for textual notation is equally important. For this, we propose two options to industry partner. First one is the natural language-like syntax, and second is the programming language-like syntax. The team at Volvo prefer the programming language-like syntax because the engineers and developers are more comfortable with this. So we use EA-Top modeling workbench for proof of concept. It is the de facto development environment at Volvo. And finally, we use the car wiper case study for demonstration. So this is the interface of the EA-Top here. System modeling can be done using different EAST-ADL package. This is the car wiper model, and this can be represented in EXML. Here, EXML serves as a synchronization point. So we implemented the timing and variability X-text grammars, and as we already discussed, this allows us the two editors to support the modeling in textual notations. So we implement the step 2 deserialization and information extraction in Java in XML DOM. And for the change propagation from graphical or EA-Top to textual editor is done using the Java. And we implement the EXML transformations in Extend and Java to convert the textual model into EXML. And finally, we perform the serialization in Java. So this lead to the propagate the changes from the textual editor to the EA-Top. So this way, the real-time synchronization between EA-Top and textual editor has been done. So this is the EAST-ADL timing meta model. Here you can see timing is the main concept that contains the other concept like timing, description, and timing constraints. These concepts are further divided into different other concepts. For instance, the timing constraints allow the modeling of 20 constraints. So this is the modeling concept of EAST-ADL variability package. Here, variability is the main concept that contains the other concept for the modeling of the product variants. So this is the X-text timing grammar that we have implemented. We defined different EAST-ADL timing concepts. In the X-text grammars, our objective is to provide the syntactical sugar with temporary inconsistencies for textual notations while preserving the semantics of the meta model. So this is X-text variability grammar, snapshot of the X-text variability grammar. Here you can see different concepts, definition of different concepts have been provided. So this is the X-text editor for timing, and here you can see the user can specify different timing concepts through a programming language like syntax, like event functions, constraints. We have currently defined around 10 constraints in this. So this is the text editor for variability. So this is the snapshot of the EXML transformation that convert the textual instant model into the EXML for change propagation from textual editor to the graphical editor. So blended modeling in practice. Now I will explain the actual application of the proposed approach in the industrial setting. Here you can see the model of a car wiper. It is basically the design of the car wiper using different design level entities like design function, prototype, functional correctors, and so on. Please note here, the variability and timing related modeling is not available at the moment. So here you can see the textual editor where user can specify the timing related information in programming language like syntax. Here you can see that all the information from the EA top is available in the textual editor. Like all the design function prototypes and other information is available here. So in the textual modeling, one can use this information. So here you can see the timings we defined in the textual editor are now available in the EA top. So this way the runtime synchronization works. That things we define in the textual editor are available here, and the things we define here are available in the textual editor. For instance, here we define another event function blended. So you can see it is immediately available in the text editor. So the proof of concept implementation, case study model, user manual, and video demos are publicly available at GitHub. So you can further explore this. So in this work, we report on our language engineering work toward the provision of blended modeling for EAST-ADL to support seamless graphical and textual notations. So this significantly boosts collaboration and lowers development time, eventually improving the overall productivity. So this research can be extended in multiple directions. For instance, one probable direction is the extension of the current approach for other EAST-ADL packages like structure, variability, and dependability. Another important aspect is the change propagation time between the notations or editors, because this is really important while dealing with the large models. So in this work, we performed the initial evaluation on the change propagation time between the editors. But more comprehensive evaluation is required. So in this context, we are working on the break-by-wire case study to provide to analyze this in broader context and to optimize it where needed. So, thank you.
Thank you very much. So we have some time for a few questions, and we'll have some help for circulating the mic. So yeah, please head.
Thank you. It's a very important topic, actually. But trying to follow what you have done and what was future work, but I didn't actually see any graphical notation in your graphical editor. You just had the outline. One of the issues is always doing the synchronization is how you deal with the layout when you change things. Is that addressed at all? Did you just not show that, or did you say that you haven't gotten to that?
Your question. Basically, the EA top is here we represent the EA top as a tree editor. You know, we have the plugins for the graphical. These are converted into the graphical notation. The point is we are basically using the meta models and the abstract syntax. So, and this is also based on the abstract syntax.
The tree editor is easier than dealing with the actual graphics. So that's a key area.
Yes,
there.
yes.
One other thing related to that, and then I'll hand it off for the...
I can answer the question.
Oh, go ahead.
We were working for the same project, and the company Volvo developed a graphical viewer. They can see the graphical model, but in that graphical viewer, the models cannot be edited. It's just a viewer.
Okay, so you would relay it out.
Yeah.
So you revisualize it. Once you update it, you just revisualize it each time.
Yeah, you
Okay.
cannot edit.
You can't edit. That makes it easier. That also, do you try to maintain the identity when you go to from the meta model view, where each of these elements has a specific identity, to the text and back again? Can you maintain the identity of elements?
Yes. Yeah. Yes. I think the idea is that they have already have a tree-based syntax and they also have the graphical syntax. They both adhere to the meta model, and now they use the same meta model to generate a textual syntax. So the textual syntax is also adhere to the same one meta model, and the models in different notations can interact with each other.
I'll follow up with you later, because when you reparse an X text, usually it regenerates everything.
Can you use the mic? Yeah, because we are live streaming, so that's why we try to keep the mic.
The question was on how you do the incremental update without reparsing everything, but I'll follow up afterwards. Thanks.
I think there was another question, Andreas.
Thank you. So thank you for the talk. I'm wondering if you wanted to translate what you have learned and done for EAST-ADL to another popular architecture description language such as AADL or Monty-Arc, what would you have to do?
Sorry, please repeat the question.
How can I translate your results to another architecture description language?
I think the question is how you can generalize what you did for EAST-ADL for another language, and more specifically for another architecture description language.
I have no idea about the architecture you had.
Okay, might be future work. Thank you.
Thank you.
As a guess, it would seem like any language you could express in X text with an underlying meta model, you could use this same approach. I mean, you could use it in other technologies, but you'd need a parser and.
Yeah, but it's not generic, right?
The mic, can you use the mic, Andreas?
So thank you, Ed. But I think this is not generic. So there are some parts that might be specific to EAST-ADL and some parts that seem to be generic. And I try to understand exactly.
The steps looked pretty generic. If you had each of these pieces and an underlying XML representation.
I think there are some technologies that can be generic to other languages. We had a paper before to talk about how to extend the X-text generator's capability and and also its implementation. So that technology has been described in that paper, and it can be used in other languages. And here I also want to ask the author, because we were working in the same project, and we developed a textual language for EAST-ADL as well, and we have also have a working paper for the blended modeling on EAST-ADL. I'm very surprised you also write this paper. I remember that you were working in another language called Artist. So it's I think you should let us know. I think, yeah, because we have we share the code. You can see our code. So I'm. Yeah.
Thank you very much. There is another question just there.
Thank you for your talk. My question is related to EXML transformations. So you mentioned you use Java. Is there any particular reason you use Java and not any transformation language?
Basically, we use extend, and this can be done through the model-to-model transformation as well. But in this case, we have to provide some temporary inconsistency in the textual grammar. Because we need to propagate the result of the verification back to the model. So for this reason, EXML is more suitable for us.
Nice, thank you.
Is there any last question to Muhammad? Okay, I will have a few seconds for asking you my question. So you discussed about how to combine textual and graphical modeling, but my question was more about which part should be textual and which part should be graphical, and which textual and graphical syntaxes future users are expecting. So my question is, how did you involve the future user of this language in order to define what should be graphical, what should be textual, and for each part, what should be the keyword, for example, for the textual one, and what should be the graphics for the graphical one? How did you engage the future users?
Tool is already available here, EA-Top. So in EA-Top, you can develop the tree-based modeling and you can visualize it as a graphical model. While in the X-text grammar, so we provide the textual syntaxes. Most of those are equivalent to these graphical notations. But there are a few temporary inconsistencies. There are few additional elements in the X-text grammars. So that we will use in different other contexts, like the propagation of timing constraints, verification result back to the models. So this is not suitable using the graphical notation, because for this reason we have to update whole meta models.
Okay, so that's for the choice of the graphical
Yes.
versus the
Yes.
textual one. And then for the choice of the different keyword, for example, in your grammar. So in the X-text grammar, you have chosen some keywords.
Yes.
You have chosen a programming language style, as you said.
Yes.
Everything has been chosen by involving the future users, or is it choice
Yes,
that you made by own?
Of course, the Volvo team was involved, and they recommend. I already told we proposed two syntaxes, like natural language syntax and the programming language. So the team at Volvo were involved about this,
Okay.
and it is based on their recommendation.
Super. Thank you very much.
Thank you.
So I think we can thank again Muhammad for the presentation and the answer of the question. Thank you very much.